in integers. Associative property. If a, b and c are integers, then a minus b minus c not equal to a minus b minus c. Example, 9 minus 3 minus 4 is equal to 6 minus 4, which is equal to 2, and 9 minus 3 minus 4 is equal to 9 minus negative 1, which is equal to 9 plus 1, which is equal to 10. Therefore, 9 minus 3 minus 4 not equal to 9 minus 3 minus 4. Therefore, associative property of subtraction does not hold true in integers. Multiplication of integers. In order to multiply integers, we follow the following rules. Rule 1. The product of two integers with like signs is equal to the product of their absolute values with positive sign. Examples. 4 into 6 is equal to 24. Positive into positive is equal to positive. Negative 5 into negative 4 is equal to 20. Negative into negative is equal to positive. Negative 8 into negative 9 is equal to 72. Negative into negative is equal to positive. Rule 2. The product of two integers of opposite signs is equal to the product of their absolute values with negative sign. Examples. 4 into negative 9 is equal to minus 4 into 9, which is equal to negative 36. Positive into negative is equal to negative. Negative 8 into 7 is equal to minus 8 into 7, which is equal to minus or negative 56. Negative into positive is equal to negative. Properties of multiplication of integers. Closure property. If a and b are integers, then a into b is an integer. Examples. 6 into 5 is equal to 30, which is an integer. 8 into negative 6 is equal to minus 8 into 6 is equal to negative 48, which is an integer. Negative 4 into 9 is equal to minus 4 into 9, which is equal to negative 36, which is an integer. 0 into negative 7 is equal to minus 0 into 7 is equal to 0, which is an integer. Therefore, integers are closed under multiplication. Commutative property. If a and b are two integers, then a into b is equal to b into a. Example. Negative 6 into 7 is equal to minus 6 into 7, which is equal to negative 42, and 7 into negative 6 is equal to minus 7 into 6, which is equal to negative 42. Hence, negative 6 into 7 is equal to 7 into negative 6. Therefore, the product of two integers remains the same, whatever be the order of multiplication of integers. Associative property. If a, b and c are three integers, then a into b into c is equal to a into b into c. Example. 7 into negative 4 into negative 2 is equal to 7 into 8, which is equal to 56. And 7 into negative 4 into negative 2 is equal to negative 28 into negative 2, which is equal to 56. Hence, 7 into negative 4 into negative 2 is equal to 7 into negative 4 into negative 2. The product of three integers remains the same, whatever be the order of multiplication. Therefore, the multiplication is associative over integers. Multiplicative identity. If a is any integer, then a into 1 is equal to 1 into a, which is equal to a. Examples. 12 into 1 is equal to 1 into 12, which is equal to 12. Negative 5 into 1 is equal to 1 into negative 5, which is equal to -5. One is called the multiplicative identity property of 0. If a is any integer, then a into 0 is equal to 0 into a, which is equal to 0. Examples: 0 into 6 is equal to 6 into 0, which is equal to 0. -5 into 0 is equal to 0 into -5, equal to 0. Distributive property of multiplication over addition. If a, b and c are three integers, then a into b plus c is equal to a into b plus a into c. Example: -4 into -5 plus 3 is equal to -4 into -2, which is equal to 8. And -4 into -5 plus -4 into 3 is equal to 20 plus -12, which is equal to 8. Hence, -4 into -5 plus 3 is equal to -4 into -5 plus -4 into 3. Multiplicative inverse. Multiplicative inverse of non-zero integer a is 1 upon a. A into 1 upon a is equal to 1 upon a into a, which is equal to 1. Examples: multiplicative inverse of 7 is 1 upon 7. Similarly, 7 into 1 upon 7 is equal to 1. Multiplicative inverse of -8 is -1 upon 8. Similarly, -8 into -1 upon 8 is equal to 1. Division of integers. Like the whole numbers, division of integers is inverse of multiplication. Dividing 18 by 3 implies that we have to find an integer which, when multiplied by 3, gives 18. Obviously, such an integer is 6. 18 divided by 3. Let us recall few definitions relating to division. Dividend. The number to be divided is called the dividend. Divisor. The number which divides is called the divisor. Quotient. The result of division is called the quotient. Remainder. The number that is left over in division is called the remainder. To find the quotient of two integers, we have the following rules. Rule 1. If two integers are both positive or both negative, then absolute value of two integers are divided and positive sign is assigned to the quotient. Examples: 12 divided by 4 is equal to 3. -42 divided by -7 is equal to 42 divided by 7 is equal to 6. Rule 2. If two integers are of different signs, then absolute value of two integers are divided and negative sign is assigned to the quotient. Examples: -26 divided by 2 is equal to -13. 24 divided by -6 is equal to -4. Properties of division of integers. Closure property. If a and b are integers, then a divided by b is not always an integer. Examples: -14 divided by 2 is equal to -7, which is an integer. -15 divided by -3 is equal to 5, which is an integer. -7 divided by 2 is equal to, result is not an integer. -13 divided by 3 is equal to, result is not an integer. If a is an integer such that a not equal to 0, then a divided by a is equal to 1 and a divided by 1 is equal to a. Examples: 7 divided by 7 is equal to 1. -8 divided by -8 is equal to 1. -9 divided by 1 is equal to -9. For any non-zero integer a, 0 divided by a is equal to 0. Examples: 0 divided by 6 is equal to 0. 0 divided by minus 6 is equal to 0. If a is an integer, then a divided by 0 is equal to a upon 0 is not defined. Example: find the quotient in each of the following cases. Negative 63 divided by negative 9. Negative 63 upon negative 9 is equal to 63 upon 9, which is equal to 7. Word problems. Example: in a class test containing 10 questions, 4 marks are given for every correct answer and negative 2 marks are given for every incorrect answer. Naresh attempts all questions, but only 8 of his answers are correct. What is his total score? Umesh also attempts all questions, but gets only 6 answers correct. What will be his score? Solution: correct answers is equal to 8. Marks given for 1 correct answer, 4. Marks given for 8 correct answers is equal to 8 into 4, which is equal to 32. Marks given for 1 incorrect answer is equal to negative 2. Marks given for 2 incorrect answers is equal to 2 into negative 2, which is equal to negative 4. Total score of Naresh is equal to 32 plus negative 4, which is equal to 28. Therefore, total score of Naresh is 28.